Okay, this is ELEC1 2019 question 7. An instrument system monitors the temperature of a commercial freezer. The block diagram for this system is shown below. We've got a temperature sensing unit going into a difference amplifier to an ADC to a display. This diagram shows how an NTC thermistor, or a negative thermal coefficient thermistor, is used in the temperature sensing unit. So we've got this diamond of resistors with a thermistor, a variable resistor, and two standard fixed resistors. And the first part of this question is, what is the name of this type of circuit? Well, this is known as a bridge circuit. It's one of those circuits you've got to be able to recognize. Okay, part 2. Calculate the output voltage Vout when the variable resistor is set to a resistance of 2 kilo ohms and the thermistor has a resistance of 1.75 kilo ohms. Well, for this, what you need to recognize is that Vout is the difference between two potential dividers. You have a potential divider on the left-hand side, the two fixed resistors, where you're measuring the voltage in between those two fixed resistors, and you've got a potential divider on the right hand side where you've got the thermistor and the variable resistor. So what we need to do is measure the voltage or the potential at point P and point Q, and the difference between those will be Vout. Okay, so for Vp, the calculation we're going to do is 2 kilo ohms over 2 plus 2, or 4 kilo ohms. And we're going to multiply it by 12 because that's the voltage of the supply, and therefore the voltage at point P is going to be 6 volts. What about the voltage at Q? That is going to be the thermistor's value, and we're sort of told that, the variable resistor's value, which is 2 kilo ohms, and that's going to be divided by the total, which is 2 plus 1.75, or 3.75 kilo ohms, and we're going to multiply that by 12, and that comes to 6.4 volts. Now what we want to do is measure the difference. Now if you follow the lines, the voltage is measured from the lower voltage value to the upper value. So we know that this top line Q is going to be 6.4 volts. We know that the bottom one is 6.0 volts, and therefore Vout is going to be 0.4 volts. If it was the other way around, with the 6.4 on the bottom, Vout would be minus 0.4 volts. Okay, B part 1. Now nationally, this question was done very, very poorly for all parts, and so it's worth paying attention to the outcomes as far as these questions are concerned. So the output of a temperature sensing unit is amplified by connecting points P and Q to the inputs of a difference amplifier. In some electronic circuits, it's important to keep connecting leads between subsystems as short as possible. Why is this important? Well, the first thing to realize is that leads act as aerials. So leads act as aerials. Oh, sorry, let me just correct that spelling. And in doing so, they detect noise. And in general, longer leads detect more noise and noise of a greater amplitude. Okay, part 2. It says, in this circuit, that precaution is less important for the connecting leads between P and Q and the difference amplifier. Explain why this is so. Well, the key to this is difference amplifier. The difference amplifier amplifies the difference between the two connecting leads. So, first thing to realize is that the leads will be the same length. So leads leading to the difference amplifier from your bridge circuit will be the same length. And what happens is the difference amplifier will only amplify the difference in P and Q. So difference amplifier only amplifies difference in P and Q. Now what you're hoping is that it's going to ignore the noise because it would be identical in both leads. So as noise is identical in both leads, and what you're hoping is that the leads are side by side, so any instant noise has the same effect on both of those leads. So as noise is identical in both leads, the difference amplifier ignores the noise. Okay, part 3. Now the third part of this question is down to a calculation and a circuit diagram. And it says when a temperature sensing unit output voltage Vout is minus 0.3 volts and the output of the difference amplifier needs to be 9 volts, design a suitable difference amplifier based on a single op-amp. Draw a circuit diagram showing the difference amplifier connected to the temperature sensing circuit. Label all resistors with their values and show all necessary calculations. Well, the first thing to know is that you're talking about this circuit. All right, you've got to remember difference amplifier. You've got 4 resistors, you've got 2 inputs, 1 output, and it's this configuration. And if we were to label the inputs, this is the inverting input, this is the non-inverting input. Now all we've got to do as far as this question is concerned is try and figure out what the values are for the 4 resistors, but at the same time realize that we know that A and B are the same value and C and D are the same value. All right, so how do we go about this? Well, we're going to use the information there of the, when the temperature sensing unit's output voltage Vout is minus 0.3 volts and the output of the difference amplifier needs to be 9 volts. Well, that means Vout is 9 volts and the difference into the difference amplifier is minus 0.3, and that is the voltage going into input 1. And we can use the inverting gain calculation because we know that gain is equal to Vout over Vin, and because this is inverting we've got to put a minus there, and what that means is that we're going to have minus 9 over minus 0.3, and that gives us a gain of 30. Now why this is important is because we can treat C and A as our inverting amplifier resistor values, where we've got RF and RIN. Now that gain of 30 basically means that RF is equal to 30 times RIN for this particular configuration, which means that if we want to use values, we'll basically give RIN the easiest value that we can and the smallest value, which is 10k, which means that RF will have to be 30 times bigger than that, so that's going to be 300k. And now we can give all of the values, because what this means is that the resistance of A is equal to the resistance of B, and that is going to be 10k. And the resistance of C is going to be equal to the resistance of D, and that is going to be the higher value of 300k. And that concludes question 7.